Something extraordinary is unfolding in astronomy right now. The interstellar comet 3I Atlas, a traveler from beyond our solar system, has shocked scientists with a mysterious signal. From nickel without iron to a tail pointing the wrong way, every observation forces us to rethink what we thought we knew about the universe. And if these findings hold, they may reshape how we imagine distant star systems, the origins of planets, and even the possibilities for life. 1. Unveiling the signal. The signal from 3I/Atlas was unlike anything astronomers expected. Right from the start, the data revealed something shocking: abundant nickel without its usual twin, iron. Across the cosmos, these two elements are inseparable, forged together in the hearts of stars. Yet here was a comet breaking the rules of chemistry, forcing scientists to question everything they thought they knew about how planets and star systems form. The very first surprise: nickel without iron. Everywhere we look in the cosmos, asteroids, planets, meteorites, even the dust around stars, nickel and iron show up together. That's because they form under the same nuclear conditions in stars. They're cosmic twins. Yet 3I Atlas displayed abundant nickel, but virtually no iron. To geologists and astronomers alike. Why is this shocking? Because it suggests that 3I Atlas didn't form in an environment like ours. Something about its birth conditions, possibly in the debris of another star system, allowed nickel to separate from iron in ways we've never seen. That's a window into alien chemistry we didn't even know was possible. Then came the second red flag: carbon dioxide domination. All comets release gases as they warm up near the sun. Typically, we see a mix of water vapor, carbon monoxide, and some CO2. But 3I Atlas was blasting out CO2 at levels far higher than expected, almost overshadowing everything else. That suggests it formed in an environment much colder or more chemically skewed than the outer reaches of our solar system. In other words, the recipe for this comet's formation was completely different from ours. And as if that weren't enough, scientists spotted a bizarre feature in its tail. Instead of simply streaming away from the sun, the comet developed what's called an antisolar tail, pointing sideways or even toward the sun under certain conditions. That defies normal solar wind physics and hints at unusual dust particles, electric charge interactions, or structural instabilities inside the comet itself. So the signal here isn't one thing. It's a trifecta of anomalies: nickel without iron, CO2 dominance, a tail that refuses to behave. Each one of these would be extraordinary on its own. Together, they point to something truly alien, a celestial messenger breaking all the rules. 2. Why it matters. Why should we care about one strange comet? Because in science, anomalies are where revolutions begin. Think about the history of interstellar visitors. In 2017, we met Oumuamua, the first known object from another star system. It didn't behave like a normal asteroid or comet. It sped up without explanation, leading some to speculate about non-natural origins. Then, in 2019, along came 2I Borisov, a much more typical comet, but still bearing chemical signatures that marked it as foreign. Now, with 3I Atlas, we've entered a new chapter. A comet not just unusual in shape or speed, but chemically and physically unlike anything we've cataloged. Why does that matter? Because chemistry is destiny in the cosmos. The composition of a star system decides whether planets form, whether those planets keep atmospheres, and what kind of chemistry fuels life. If 3I Atlas has a composition totally unlike anything in our solar system, it shows us that planetary systems across the galaxy can be built from wildly different ingredients. That means worlds out there might not just look different, they might follow physical rules we haven't even considered. This also connects directly to the origins of life. On Earth, many scientists believe comets delivered water and organic molecules to the early oceans, seeding the conditions for life. If interstellar comets are chemically diverse, then the potential pathways to life in the galaxy are even broader. A world seeded by a 3I Atlas-type comet could have life built on chemical foundations totally unfamiliar to us. And let's not forget the astrophysics angle. Normally, when we study distant systems, we only have light to work with, spectra from stars many light years away. But an interstellar comet is like a sample return mission delivered to our backyard. It physically carries the material of another system right past Earth. That's priceless, Because it gives us direct access to alien chemistry we could never otherwise touch. So why does it matter? Because this single comet might reshape how we think about the building blocks of planets, the possibilities of life, and the very diversity of the cosmos. It's not just a rock passing by. It's a messenger reminding us how little we know. 3. How we study it. The study of 3I Atlas has been a global sprint against time. Interstellar comets don't linger. They swing past the sun once and vanish back into the dark. So scientists threw everything they had at this object. On Earth, giant observatories like the Very Large Telescope in Chile and the Keck Observatory in Hawaii tracked its spectra night after night. Meanwhile, space-based powerhouses like the James Webb Space Telescope and the Hubble Space Telescope joined in, peering at wavelengths Earth's atmosphere can't see. The method is straightforward in concept but complex in execution. Capture the comet's light, split it into a spectrum, and read the fingerprints of its chemistry. That's how they found the nickel anomaly, the CO2 dominance, and hints of unusual dust. Every telescope added a layer of confirmation, like detectives checking the same fingerprints under different lights. But chemistry wasn't the only focus. Astronomers tracked its orbit with exquisite precision. Unlike local comets, which follow predictable elliptical paths, 3I Atlas came in on a hyperbolic trajectory, a one-way ticket from interstellar space. By measuring its speed and curvature, scientists confirmed it wasn't bound to the sun. It truly came from another star system. Then came the tail puzzle. Images revealed dust streams pointing in odd directions, suggesting forces at play beyond simple solar wind. Could electrostatic charging explain it? Was the dust unusually large or oddly shaped? Or was something happening inside the comet itself, destabilizing the material? Each possibility deepens the mystery. What makes all this even more remarkable is the international cooperation. Teams across continents shared data in real time, knowing the window was closing fast. 3I Atlas won't be back. Every photon captured now is a piece of cosmic history that will never repeat. In the future, scientists are already sketching out missions to chase the next interstellar visitor. Imagine a spacecraft pre-positioned in the outer solar system, ready to launch the moment a new object is spotted. It could sample the dust, measure the gases, even photograph the surface up close. If 3I Atlas is any indication, the next visitor might hold secrets we can't afford to miss. 4. Alien chemistry revealed. So what does all this strange chemistry actually mean? Let's break it down. Nickel without iron tells us that 3I Atlas formed in a place where stellar processes or disk chemistry diverged sharply from what we know. Maybe the parent star's environment lacked iron. Maybe shockwaves or magnetic fields segregated the elements differently. Either way, it's a fingerprint of a star system unlike ours. CO2 dominance suggests the comet condensed in an environment extremely rich in carbon dioxide ice, perhaps further from its parent star than Pluto is from ours, or in a system with a radically different carbon-oxygen balance. That implies star systems can host icy bodies that are chemically tilted compared to our expectations. And then there's the antisolar tail. This may point to dust grains electrically interacting with plasma, or to structures inside the comet releasing jets in unpredictable ways. Either scenario suggests that the comet's physical nature, its porosity, dust size, or electric charge, is alien compared to local comets. Put all this together, and you get a startling picture. 3I Atlas isn't just chemically odd, it's a sample of a star system that plays by different rules. That's what makes it so valuable. It's not just an outlier. It's proof that the galaxy produces far more chemical diversity than we thought. And here's the kicker. If one interstellar comet is this strange, then countless others are out there, each carrying its own recipe. We might only have seen 3 so far: Oumuamua, Borisov, and now Atlas. But billions must exist, drifting silently between the stars. Each one could be a messenger, carrying the unique DNA of its home system. 5. The bigger picture. Stepping back, what does the saga of 3I Atlas really tell us? First, it reminds us that the universe is still a place of surprises. Even in 2025, with our advanced telescopes and deep catalogs, nature throws us curveballs we can't explain. That humility is part of what makes astronomy so thrilling. Second, it shows us that interstellar objects are more than curiosities. They're samples from other worlds, drifting freely into our reach. Every one is a once-in-a-lifetime chance to learn about environments we'll never visit. They're the closest thing to a free interstellar mission humanity will get for decades. Third, it pushes us to prepare. If we can launch probes to intercept the next interstellar comet, we won't just watch. We'll touch, sample, and analyze alien matter directly. That could rewrite chemistry textbooks, planetary science, and even our understanding of how common life might be. And finally, it sparks imagination. If star systems can produce comets this strange, what do their planets look like? What exotic oceans or skies might they host? And could life, born of such alien chemistries, exist in forms we can't yet conceive? In short, 3I Atlas is more than a comet. It's a cosmic whisper, telling us the universe is stranger, richer, and more diverse than we dared to imagine. The mysterious signal from 3I Atlas isn't a message in the sci-fi sense. It's something deeper. It's the chemistry, the light, and the behavior of a comet that refuses to fit our categories. Nickel without iron. A tail that points the wrong way. A dominance of CO2 that defies expectations. Every detail forces us to ask, what else is out there, waiting to surprise us? As 3I Atlas speeds back into the dark, it leaves us with more questions than answers. But maybe that's the point. Each visitor from interstellar space is a reminder that discovery isn't over, it's only just beginning. Thanks for watching. Share your thoughts below, and don't forget to like, share, and subscribe. For more, see you next time.